Hello, hello, hello. Put that on that screen. There we go. There we go, go, go. All right, let's look. So, don't like how this doesn't like anonymous. That's just kind of weird. Everybody loves anonymous. Anonymous or private. So, event 8. It's fine with that. Seems like such a pain in the butt. As far as that one goes. Like if we do this in assembly, I think it's a lot easier. Actually. Other than the memory protection piece. Define byte. Define all these as bytes. That's our move operation. Which we could just do a quad word, but that would be too easy. Okay. So the problem with it being in the data section is it is... I mean, I guess it doesn't even have to be in the data section. A disassembler should see it. So like, if you had a function foo, and you put that in the text segment, it probably would assemble. Yeah. And it's doing a push and a pop, so we could actually say call foo. And debug it. And from this perspective, it's a function, even though we didn't define it as such. But it is, right, from a disassembler standpoint, it is code, so it should get disassembled appropriately. So we got a push, a pop, a move, and a ret, or what those instructions are. So that's good. Now, I guess the question is, do we want to... So we can either declare our buffer here. Right. So this is just calling it from C. I guess the question is, what are these arguments? So let's go ahead and say you int, what does mmap take in? So the protection is an int. Okay. So you int 32t. So we can do protection, and I think the next one is like the type, flags. That's also an int. So flags is these two. Like, there's also just changing protections in general. Yeah, it still wants to complain about that. Got my fan going. Hopefully, you guys can't hear that. It's a whole 95 outside and 80 degrees in here, so that's good. I just want to print off these flags. I want this in hex. I don't want to look them up. So, go ahead and make and this is probably, no, I thought I fixed this. Make file. It should. Pretty sure I hit save. Make -b. Well, why is it? Oh, that's because I called this overwrite, not main. Oh. That is what I get for doing that. Okay, so A dot out. Okay. So the flags is that, the protection is that. So 22 and 7. I'm ordering it, Uber. I ordered a piece like this. I don't have it yet.
So I don't need to grind anything right now?
Correct.
Okay. Gotcha. You didn't explain it very clearly.
Nope, I did not.
Oh, another thing. Give me a sec.
Okay.
Oh, I wanted to cut down a tree, but I don't know what tree I want to cut down. This is the axe, because you don't want to use the saw.
Oh, okay. Go down in the bottom and find a dead one.
What one?
There's one that broke during the storm.
Okie doke.
Since you need something to do. Okay. Okay. So our arguments. So the first one's null, as in move. Can I do push? Push. No, we don't push it. Move RDI. Let's cut this up here. I always forget. Move RDI 0. Move RSI. I should pull this over so I can see it. So that's the size. Okay. I can't type. Move RDX. Is the protection, which I said was 7. Move RCX. Yep, is 22. Then we got -1. That's an R8. Perfect. Call M app. Yeah. That's my comment. I wonder what the man page says for this. So this is if you're doing memory map for an address, which we're not doing it. We want to allocate it. The size. Hey. That's wrong. This is the flags. What are the last two? The file descriptor and the offset. Oh, goodness. We also need to declare mmap, and then our results should be in RAX. That's a pointer to the new address, right? So if we, I think reading this, right? So it can create a new mapping. So if we give it an address, we could change it. So that's one way to do it. do it. So now RAX has the address of the memory, right? So this should allocate. This will allocate memory. And then we want to copy. I'm going to take this out of foo. We'll put it in the data segment. I think this does the current location minus the buffer's address. Should give you the length of the buffer. I think that's what that does. The Copilot helped me out there, so that's good. All right. So then we need to copy the buffer len, so that load that address. Get the value of that address. Okay. We then want to move into the original definition of RDI is destination, RAX, and RSI. We need a relative. We want to get the address of this. If I can type a bracket, get that address. And then we want to move into let's see. Move into RAX. The value at RSI. And then move RAX into there. And actually, so I would like this to be a byte. So I should just be able to say AL. And I can move AL there. And then I can loop to the top. I just found out, like, so NASM local label. I think they have a local label. Oh, why does I don't want the personal trainer? See, it says official. Local labels. So if it's got a dot, it's a local label. So I did not know that. We also want to add our. So RSI already has that, so we should just be able to add our offset. Leave the buffer. We need to add to RSI ECX. Let's see, loop. What does loop do in assembly? I think it decrements ECX. So then it'll. I don't really want to copy it backward. So we're doing compare. Oh. Alright. Let's use R9. Move R9, 0. Here we can compare R9, RCX, jump greater than or equal to, less than or equal to, redirect, execute top. Let's put a comment in here. So all of this is to copy the buffer to the memory. Yep. Hey, look at that. It's helping me out. My chat jippity is helping me out. All right, so we need to increment our R9. So add 1 to it. Do a compare. On our add, we need to add R9. Or we could just add 1. Right? Every time we're adding 1, R9 gets incremented there. So we could just increment RSI. Let's do, oh, I gotta save. Let's do a make. Oh, call mmap with respect to PLT. Okay. Perfect. Seg fault. I didn't even think I called it. Oh, because I tried to call, I think I called foo in my main. No. What did I call? Oh, I am calling foo. Call RWX. Here we go. Well, let's debug it. If you guys ever have questions, feel free to put them in chat. I keep it open. Okay, so here's my disassembly. So step, we'll do next instruction. I'm not going to go into the calls. Segmentation fault. Well, I guess okay, so it's on the RCX. Load. Move. Oh, well. Should be CL, so it's not. Unless Butherland is just this EQ. Oh, it may just be a value. Move RCX. Let's see. What did I delete there? Okay. That may be. There we go. So now if we debug it, break, run. Okay, so I put it at ZZ. I guess I didn't put the call. Oh, I forgot. Call. Is it RAX? No, it will not be RAX. Also, I didn't increment RDI. And I probably need something other than... So I need to save my... R10 RX. Save the address. Call R10, and we forgot we needed to increment RSI, increment RDI. So they should both move by one. Next character. Next character in the line. And of course I broke it. Call R10. Oh. Well, let's break it ZZ and see. So what does R10? Examine at that location. Okay. I guess I don't need an asterisk. That does not look like... That does not look like our data, I don't think. Yeah, it's not a function. So I thought I moved it into R10. I moved it into R10. RX should have... Well, let's look. Object dump. Sorry, I'll call it dump. .sh. A dot out. Main. So they call memrat map in the PLT. And then they grab RAX and they put it in RBP minus 10. Save some registers here because I will probably forget them. Neil. Line 42, label alone. I guess it doesn't like that. Okay, let's debug it again. Run. Where did we crash? Yeah, I think it's like the memory is not right. This should be an address. Move the data at that address into AL, move AL into RDI. Source should be buffer. Well, let's break here. And debug it, and break here, and run. Okay. So RAX, does that have our memory address? I think so. Looks like a memory address. Let's point to null. Move that into R10. So ECX is getting 8. So there's 8 bytes. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. RSI should have an address. Okay. Okay, so we got a C3 at the end. That's I know a return. You can see this. We got some zeros. Also good. All right. Oh. I shouldn't increment those till the end. That's definitely wrong. Now they're pointing to byte 2. So we should not increment these until down here. That's definitely wrong. Now the debugger or a disassembler will see that as code, right? It looks like a function, walks like a function. It's probably a function. They can probably track the fact that we copied, right? We have basically a memory copy here. Like you could call mem copy, and it should do the same thing. There we go. So they would recognize this as M copy, probably. And we can look at it. So if somebody does this, and that'd be a pointer. Let's see, what function is that in? Library. String. Warning. Ah. So. Alright, so it's calling memcopy. But if you do like -04, maybe. It's still it's still calling it. Sterling should have, okay, how long it is. Load the address of being bombarded by my teenager. So here it's adding to RWX. So load address RWX +1. I guess it's just loading it right in, doing the math of adding RWX and 1. So doing all that math at once. If we didn't have that, I mean, this is wrong, but it's just moving RX into RDX. So it's using LEA as like a math calculator, right? Apparently LEA is pretty powerful and does a lot of things. So, didn't realize I didn't have my picture on. My bad. Out of coffee. Oh, at least I'm sharing my screen. I got somebody on Twitch. You should say hello, Twitch person. So we do have a +1 in here. We want to copy that plus the null, so it will use LEA to do that. We know ahead of time how long our thing is, otherwise we'd have to go and find the null in it. I mean, we don't need it, or you can put you can put whatever thing you want. So Sterling, right, we'll just go through that string, looking for a null in there. It probably would be more efficient to grab, like in this example, you could grab a quad word. This is 8 bytes, right? 1, 2, 3, 4, 5, 6, 7, 8. So in theory, you could just do. So we need the address, but like you could just do get the address. move into, let's see, RCX, value at RSI, load, source, no, load into, load that address into, well, actually it's already there. Move into RAX, RCX. So that will do I think that works. Yeah. Because it just happens to be 8 bytes, right? So if you knew it was in multiples of 8, you could take that length and you could divide it by that. Now, you would have to, right? So like normally, right, a string could have any length that the programmer wanted. So you'd have to know how to look in there to see if there are any zeros. I'm not sure if there is a so in the XMM string copy. XMM search for null byte. move mask. So P is for packed. So we got a packed XOR. That zeroes this out. Compare equal bytes. Compare packed data for equal. Compare packed bytes in the memory address for equality, and the there's probably a register here. Yeah. XMM, which is compare bytes in XMM2 slash memory address 128 and XMM1 for equality. So like you could copy the 8 bytes as long as you always had enough memory allocated. You would and you'd want to check to make sure that you're like writing the right number. But this one would work because we only have 8 bytes for our function. Oh, it's not called main. Oh no. Oh, why is my... Not sure. Control C. Oh, there we go. Q. What in the heck? Oh, my server's wigging out. this one better? There we go. Okay. All right. That would be interesting, trying to use XMEM to do our memory mem copy. That'd be a fun project. Oh. I almost want to like copy them in. Reading them is going to be a pain. You could easily do a scanf and put them in, I guess. All right, well, I'm going to take this code out. I will put this code back. Yeah, it's not that much more code. So. Yeah, I think we'll save that for next time. But, so the fun part about this, right, is that if you're able to either allocate memory or, so you can use, instead of mmap, mprotect, and use that to change the memory protections. The other thing I actually found interesting is the Intel, what is it called? It's like a BBR. Bet mitigation. So they had some like new instructions in 64-bit that disable some of the it was called BR or something. I saw them in the Microsoft. I was disassembling some Microsoft code. Not sure if I don't think Linux was doing it when I looked. Well, there. So it's NBR64. So if you call a function, it has to have that in it if you are using that. So that will be fun to like, that makes makes it so you can't call those functions like you used to be able to. Like I saw this in a disassembly and I couldn't figure out what it was doing. But it is, so this is default in the compilers. CET. So end branch 64-bit. Terminate indirect branch. Because it's actually at the beginning of the function. And it checks it when you control enforcement technology. So it checks them when you call that function. It will check to see, is the next instruction this set of codes, which happens to be a no-op in old 32-bit. I read through this article the other day. Yeah, the instruction is otherwise considered a no-op. So means you're gonna have to find portions of instructions that have that in them, so that you can try and get around those mitigations. Anyway, all right. Well, I'm gonna have to go, but thanks for joining, and I'll see you guys later. Thanks, guys. Bye.